What's up, everybody? Welcome to Flux Harmonic. System Crafters. This is the day 7 of the Spring Lisp Game Jam 2024. Let me just make sure that the post I made went out. We are working on a game called Land a Dungeon, which is a kind of a reverse dungeon crawler. It's a game where instead of playing the hero, the quote-unquote hero, you play the monsters that are in the dungeon. With the goal of preventing the hero from stealing all the treasure and escaping. Hey, Dave. And hello to Thanos as well. So the way that you play this game is not by using the keyboard or mouse, it's by writing scripts for the logic of the monsters. And yesterday we came up with a strategy for how the game flow should work, or the game loop should work. Or basically, let me just restart this screen, and this is what the game looks like so far. You start off with the game paused. Nothing's running yet, but you get the chance to take a look at everything that's on the board. The hero is the red guy here, and then the monsters are randomly generated every time you restart the game. Seems like we're not getting any green guys. There we go. There's a third one there. So you take a look at what's on the board, and then you write scripts for all the monsters that are available to tell them what you want them to do, and then you click run, and then it runs the game, and then the logic of all the monsters versus the logic of the hero character kind of battle it out to see who wins in the end. There's probably a lot of things we can do to extend on that concept, but at least to get to the end of the game jam, I believe we're gonna have to, limit the scope of the gameplay, but that's okay. That's just the way that these things go with game jams. Today, what I want to try to do is get the logic for the hero character started. I think that we should be able to use a similar type of script, just one that isn't editable by the player, to implement the hero logic. I'm not entirely sure that will be the case, but that's my aim, because it would only be fair if they are able to run the same logic and there's no tricks or something. So we'll see what we can get done with that. We also need to do a few things like opening doors, maybe assigning keys to certain doors, making it so the hero can go to the exit and win. We're still, trying to get the basic loop for the game going. Another thing I was working on yesterday, a couple things I was working on yesterday, are to make the game responsive so that it's possible to play it in a mobile device. So if you were to go into the, I haven't recompiled this, so it probably doesn't work. Let me just pull up the compiler and then recompile. Maybe it does work, actually, because it's all CSS. So if you are in the game and you open it up on a phone, it should actually reposition everything so that you have the script editor at the top and the game at the bottom. I wanted to have the game at the top at first, but what I found is that when you go to the itch.io site to play this game on mobile, when you open the keyboard by clicking in the script editor, it doesn't actually slide the window up so you could see the text field. So I had to flip the order so that the text field will always be visible. But that's okay. I mean, I think it looks pretty good despite that. So the thing is fully responsive. If you stretch the screen back out, it will go back to a horizontal layout. I don't know, it's pretty cool. I think it's good enough on that end. We have the message log that we added yesterday, so I'm feeling pretty good about how the UI is going. It needs a lot of polish before it's going to be like a really good game, but at least for the purpose of a week-long game jam, it's pretty good. I'm satisfied enough with it. All right, so let's see. What do we need to do? We've got the game recompiled. Let me just refresh that, get everything up to date. So since we've got a lot of the stuff in place already, we can get right on started with the logic for the hero. So the hero's main quest is to find all of the items in the map and then escape. The hero isn't necessarily here to attack the monsters, because that would just be a waste of his time. So the only way that I think that he would try to attack a monster is if a monster had an item that he needs. So let's see. Let's open up our notes file. Let's also write up a list of hero logic needs. Find the next available item that has an unblocked path. Find an entity that is holding an item or a key, or a treasure or key, let's say. Because we kind of need to have a way to, since the monsters can pick up treasure because they're trying to keep it from the player, I guess the purpose of a monster would be, I'm going to pick up all the treasure I can find and then like basically be a mobile treasure chest. I have to move away so that the hero can't get to me and take the treasure that I have so he can escape. And the hero won't try to escape unless he has all the treasure. So we'll have to see how that works. But find the next available item that has an unblocked path. Find an entity that is holding a treasure or key. Walk to the exit once all items are held. So if I were to just sort of like spec out what the hero script could look like, so we could figure out maybe how we would implement it. Let's give that a shot. Let's pull this into a script editor. All right. And if you're here in the chat today in YouTube or IRC, please say hello. Hello to Trev. PU Dev, what's that? Dave says, up early to get back to jamming and watching the stream, of course. Yes, that's awesome. I'm looking forward to seeing the current state of, what's it called? It's Cirque something. What is it called, Dave? All right, so logic. Let's see. PooDev. Circlebond, that's it, thank you. Yeah, that's a cool idea, man. That's a really good game idea. Kind of mixing a couple different concepts together. PooDev, That should be my new channel name, I think. Or it could be Cal 2001's channel name. So, logic. So we need to find any available items. It could be any item. We're not filtering. So take item. To find nearest item could be one. Let's see. It's possible that find nearest item could return the location of an enemy. Sorry, a monster. Returns location of an item or monster holding an item. Okay. The next would be, did we write that down? Somehow, basically to make sure that the, let's say that the yellow key unlocks this door here. If the hero needs to get behind this door to get something, then we need to know that. We were talking about this yesterday. We need some way to know that the path to the only remaining item is blocked. So in our, find nearest item should find the nearest available item no matter where it is, and then go to take it. Then if you can't find an item because the path is blocked, path blocked, let's call it. What does it even mean, I guess? Also, doors are kind of pointless unless they're locked. I suppose that a monster can pick up a key and go lock a door to assign that door to that key and then hold on to that key. So yeah, so path blocked, find key. So find nearest item. We'll find whatever item is available to reach. It will start by looking at all the items that are sitting on the map, and then it will look for monsters carrying items. Then it will take the item. If it can't do this because, yeah, okay. Else, exit. Walk to exit. Okay. If path blocked, find key. Otherwise, they have the key to open the door. So they'll just walk through the door. They'll unlock the door and walk through it. Is that all the logic we need? It seems a little bit too simple. That's okay. I mean, like, this is not the best logic in the world. It would be better to have a more full language to do all this. But we'll deal with what we got. Let me see what else, what other ideas I had here. Has item yellow key, unlock door. I was going to add some logic like this. Let's see. Trying to think of how I would do it from the reverse side. So for the monsters, if I want a monster, like let's say I want the green guy here to go grab the yellow key and lock this door, what would be the sequence of steps? First, you would want to find the item, the yellow key, and take it. And then you'd want to tell it to go to this door to lock it. Maybe like has item key yellow, lock door. Maybe that will lock a random door, or perhaps we can give a door position. I would also need to have like a hover here to tell you what the tile position these things are. That way it's easier to understand where you are on the map. That's possible. Let's see. Also, if the hero is near, you want to flee. Maybe you don't want to do that. Maybe one of them wants to go fight him. It could be either flee or fight. I think I want to change else to do also. Do is basically like a directive. Instead of having a predicate, then you just have a directive instead. In fact, let's go in the code and change that. That would be an entity, I think. Else. So we'll change that to do. Also, we'll check for else in here because I think there's a default script that has it. Whoops. Else. Do. That's it right there. Okay. A dislike W. All right, so that's good. We will change our notes to reflect this as well. Come on. Oh, that's because I have the editor up right here. Okay. So we'll change this else to do also. All right, so find nearest item. I suppose find item could just, it could just be find item. That's kind of lame. Doesn't seem readable, as readable. All right, so find nearest item, take item, path blocked, find key. I mean, maybe that's it. Simple. And also, if you're walking on a path and the door is closed, if it's not locked, then you can just walk right through it. The pathfinding should just take you right through it. All right, so a couple things we need to do. Let's go into the map. We want to add a doorway. I don't know if that's a good one, or where's the other door we're using? Oh, right here. Okay, so that's an open door. That is tile 551. So we can put a door tile, where is it? Right here. Put a door tile here. We're just going to put normal door tiles around. And those will be the signifier for the game to note their door positions. We kind of need to change up the levels a little bit too, but we haven't really gotten there yet. So I can save this level. I can actually export it as well. So export. Okay, that should be exported now. Then back in the code, go back to, what is it, level? We should also have a list for doors. That would be, what did I say that was? 551. Doors, open doors. We also need to have closed or locked doors as well. So, we don't know what the associated key is. Not yet, at least. It'd be nice if I could colorize a door. I might have to edit this file. Yeah, how about we just tweak it up a little bit? We have in the tile map, so the gems, there's yellow, okay, the keys, yellow, blue, red. All right. So now for doors, what I want to do is copy what appears to be our locked door. I'm going to paste it over here. All right. Not exactly. I think it's like one more over. There we go. And then we're going to paste it again. Is that okay? All right. So now we're going to change the colors. I can use a little magic wand here, maybe. Do an additive selection. Okay. We can, I think that we have yellow already. We can try to drop this color in. All right. Stop that. All right. So then the next is the blue color. I think this is going to be this blue up here. So I can just go steal that color. And then we're going to edit this door as well. I probably don't need to do the selections. So just hit the color in. And then the red color to go for the red door. There we go. Drop that right in there. So now we have colors. We're going to overwrite the colored packed tile set. And now we should be able to... Yeah, so we're going to have level doors. I don't know if we need that exported, though. Let's, let me think about that for a second. Yeah, we do need it because the entity logic needs to find them. And I don't know if tile sheet needs to be the one that knows the answer to whether something is a door or not. What if I go to tile sheet? So we have tile walkable, define, tile is door, tile ID, define tile is locked door, tile is, yeah. Tile ID, color. So this would be like, and equal. Well, just equal, I think. Yeah, equal. Color and case tile ID. Now let's do this down here. And what were the others? It was This is tile number 548, 49, and 50. Great. They're all right next to each other. 548. 548, yellow door. So tile is door. And also we need the walkable. Plain floor is walkable. That's something I forgot to change yesterday. So 551. Actually, I could do that here, I think. Who is QWOD? That's from another refresh of the game, I think. Okay, so that's 0, 551. Those are walkable. What else is walkable? I think the spawn point for the hero, that's in level. Spawn. That would be number 3. I guess it doesn't matter though. I mean, it doesn't really need to go there. So the exit tile would also be 298. Would be walkable. Floor, open door, exit tile. Okay. It is open door, EQ, tile ID, 551. So 548 would be yellow. 549 would be blue. 550 is red. Then we'll close out the case. If anything else is false, and it doesn't actually have to be equal. It could be EQV, I think, because these are symbols, and they would be interned. Also, false is you know, you call that kind of a, it's just a normal value. Doesn't have anything complicated. All right, so now we have the ability to check if tiles are open doors or locked doors. That can also affect our logic for the find path procedure. So find path level. We have some stuff here. Walkable. Tile walkable. Now, we're checking for whether a tile is walkable or not. We will easily find that a locked door is in the way using this logic, but it won't tell us what key is needed for that door. So we need probably another statement here. Tile is, ooh. Let me see. I think I need to do this differently. This is not a matter of checking the color. This is just returning what the color is. So it will return false if there is no lock, but otherwise it will return the color, and that's what we can use to get that information. So we can do something like this. Licked? No, not licked. Locked door. Is that what I said? Tile is locked door. We also need to export that. And yeah, we probably do need open door. Tile is locked door. And the, yikes. Maybe I can do this. to simplify this logic about this tile ID. I'm going to take this whole little snippet, drop it in right here. And now that I have that, no, then I can use tile ID here. So we're checking not. Well, let's see. I need to save that lock color. How can I do that? So if I'm in this algorithm, we're asking to find the path. There's a couple things that need to happen. One is keep the lock color that we found in the path. And then if no valid path is discovered, return the lock color. I don't really like how this is going to end up, because we're going to end up returning some kind of weird result from this procedure. That's not the right end. And get rid of that now too. Keep that for a moment. Okay, so path. Okay, here. No, that's wander. So how do we know that it's not walkable at this point? Start the first item, it's in the start position. If closest, get closest neighbor. Okay, if there's no closest neighbor to the target position, I think what that means is that we didn't find a path. Oh, no, that's not actually true. If you agree. Okay, so yes, we're trying to figure out a way to notify to an entity that there is a locked door in their way. I mean, it's possible that there could even be a locked door in the way of an entity. So let's say if one entity locks a door and the other decides, okay, there's an item in there that I need to go pick up, then the entity would also need to go find the key. So it's needed in either way, so we can generalize this logic. What if find path was given the entity, let's say if find path is given the entity, then the needed item could be stored in the entity. We can look into that in a minute. Then also, you know, maybe we can do something here where we check to see if there is a closest for I don't really like using a define here, but for now, we could just do that. Let's see if I do that. Okay. I don't know if this gets hoisted though, but let's not worry about that just yet. Target closest neighbor. We would need to be able to test this somehow. Maybe I can insert some stuff in the game to make it possible to always have an item that shows up here for testing purposes. Another thing we need to do in just a moment is update the item generation logic, generate items, to generate a limited set of items based on sort of an available pool. Generate items. Okay. Yeah, there we go. That's good. Not item count. And we're also not going to worry about item count anymore at all. This will simplify the algorithm. So if pair item pool, then we're just going to return the items at the end. Oh, what did I lose? Level const, make item, random item. Okay, cool. Yeah, that's what we're gonna. Oh, no, we're not gonna do random anymore. We're gonna just pick it off the front. I guess the question is, do we include the item or not? So the list of possible items, we have to make a choice. Do we include the item or not? So let's say this is the actual list we pass in as the list of possible items. Just a little thing here. So generate items, level, empty list, and then that list of possible items. These are all the items that could possibly be generated in the game, but we're randomizing the selection of whether each of these gets included in the game or not. So if I say random int, that is in util. So random int, I wonder how reliable that will be. Range is two. If equal, or we could say equal, random int 2 is 1, then we const make item random int. No, we're not doing that. We're say car of possible items. Level spawn for type. Okay, yep. We're consting that onto the front of the items list. Otherwise, we return items. Then we do the cdr of possible items. This will step through the possible items list one by one. And then generate items. Yes, and then generate items will generate an item or just return the existing list to the recursive call to generate items to manipulate this items list that's going through. And then at the very end, we need to make sure not to forget to return the item list. So maybe it's better to do this null, just return items. So that should work. Where do we call generate items? Let's just copy that over. Generate items. Right here. Level, no more random in range. Come on. All right. That should be a bit more reliable. And then we can close out the items expression here. All right, generate items level. Oh, weird. Do it this way. Okay. I think that's also one too many parens. Let's cut this one here out. All right. So we've got a item generation that should only generate one each of any of these items. In theory. Maybe it's worth recompiling. I don't know if I've got something in a bad state though, so maybe let's take a look at entity. So target closest neighbor. I'm going to store something here. Define locking key be false. And in this logic, if lock color begin. Yeah, this is going to be a little bit funky, but it's okay. Set locking key to lock color. Then return true. We also want to do a not or. Then we're going to ask if tile is walkable. Tile ID. Okay, so this logic, what it does, at the location, this is actually probably not the best way to do this, because it may end up with erroneous results. What if I allow it to be a locked door? And then when I walk back through the optimal path, I check each tile ID to see if it's a locked door, and then I'll know that they can't pass. That's probably better. So what I'm doing here is a little bit wrong. Let's just delete that, put it back to where it was. And then down here in this loop, I think that's actually a better loop. We don't need this target closest neighbor thing anymore. We can just do a check in here. So I think Trev was saying something like this too the other day. Hello to Alexander. Yeah, I don't have a like Twitch chat commands for this stuff. I think if you go to well, it's codeberg.org/davidwill/lambda-dungeon. That's the place to go if you want to check out the code. If you were on YouTube, then you would see the link in the description. Okay. Let's get back to it. So we're walking through this list. Let me, in fact, drop this in because I'm going to need it. Then I'll drop in this part here as well. Put it right back here where it belonged. Kill that. And kill that as well. Okay. So if closest loop. Get closest neighbor. We first need to check though. Before we do that. So begin. Oh, I need a tile is locked. Oh, okay, that's just a tile ID. All right, got it. So level tile at level new X, new Y. This is actually going to be car of closest and footer of closest. So we find the closest neighbor. Then we check to see if the tile is a locked door. And if it is, we can shortcut. We can basically say, okay, we're bailing out. And we might need to set the, what do they call it? Entity block? No. I could probably have like entity needed key. That's kind of hard coding it too much, but nope, don't need that. Then back to blocked. Let's get rid of that. Locked right there. Set entity needed key to for the entity. Yeah, we've got the entity as the parameter now, and then the lock color. Travis says, we're back on Find Path. Had to take the headset again. What I was saying the other day is to fix the shortest path. Yeah, let me know if I can't remember what you said exactly, but what I'm doing right now is integrating the door lock state into the pathfinding algorithm. So we calculate all the stuff in the visited path. Sorry, and we calculate all the distances between positions, and then when I'm walking back through them from the target path back to beginning, I'm checking to see if any of those locations are locked doors. And if they are, then we need to save what key is needed, so that can be used in the next another logic expression for the update. Update entity. I think I would also remove that state before we start doing anything so that we don't remember it incorrectly. So before we start looping through the logic, set entity needed key, entity false. I don't know if this is like a kind of a heavy thing to be doing every frame, but clear the needed key before proceeding. No, actually, we probably do need that. Make path. So if we find path, level entity, if path, can't find a path at desired position, we probably don't need to write that out. Then, what was it I was going to add as a path blocked? So we'll have a clause called path blocked. Find item position. No. And set, sorry, entity needed key, entity. Then I'm going to return a list of key and entity needed key. There we go. And that's how to implement that one. Find item position. Yeah, it just returns position. All right, so path blocked actually is implemented now. Then we need an action for that. So the action would be let's see, take item action. Maybe it needs to be find key action. Find key action entity level clause result. This is so repetitive, I think. Find key. Let's see. Walk to action, take item action. Yeah, this is very repetitive now. Current action, new action. New action, current action. Let's see. That should work. So what we know is that the character would be blocked. And as the logic is going through, if you try to find the nearest item and it returns that you're blocked, then you run path blocked, it will return true because we're looking at the needed key value. Right here. If the key is needed, then we're going to run needed key entity. Let's just join those lines. We're returning that as a result. And then that's the item to find. To fix the algorithm, we need to pop out the unvisited point that has a minimum distance from the start instead of recursing through neighbors. Not sure I understand. I did understand what you were saying the other day, though, but I don't remember it. All right, so let's see. Find item type, path block. So find item position. Do I need to use that instead? Maybe find item position on the entity key. Level, there we go. That's better. Sweet. So if we do that, let me think about how this is going to work in the end. So find nearest item. That might try to defeat the whole logic. Yeah, I might be going back there soon, but right now I'm trying to just make sure I get this stuff right. I think it's good enough. Find path. So at the end of this procedure, if closest, tile ID, get level. Oh, I also need to go back to tile sheet and include all the other, excuse me, tile IDs, but not exactly though. Okay, you know what? I think that is a separate path in walkable. Yes. because we actually do want to check through locked doors. All right. This needs to be an or, though, I think. Either the tile is walkable or it's a locked door. Alexander says, how do you display key inputs? Which plugin is that? That is called KeyCast for Emacs. All right. So we got that in. Let's see. What else now? Find path. I want to go to the end of find path. Okay. Now we're at the end of the procedure. Lock color, set entity needed key, entity lock color. I also want to say false here. So I think that might need to be a loop. Sorry, an or. Yeah. Or an and, actually. And. No. Not an and. Okay. So this will be an or after all. So we're saying either... That's not right, is it? What I want... Got it. Got it. Okay, so this needs to return empty list or false, let's say. That doesn't work. The logic here is hard to line up. So if we have a closest neighbor to the target position, whatever that is, because we're recursively walking through the list, we get the tile at that location. We check to see if it's a locked door. If it is, it returns the lock color. If we have the lock color, we set the needed key on the entity, and then we want to shortcut out of the algorithm because we don't actually have... Okay, so and is the right thing. I keep flipping back and forth. If I say false here, this is also yeah, this is the part that's weird. If there's a lock color, I want to set the entity and then exit out. I never want to return true, though. Do I need to invert this? So if lock color returns value... What did I just say? Did I say this needs to be and? So if lock color, then set the entity needed key, and then do something to break the logic. Or lock color, then... Okay, so if... Let's go with if. I'm just being an idiot here. Hitting insert too. If lock color, then set entity needed key and return false, otherwise return true. Yeah, I'm trying to short circuit if I find a locked door. I think that's just the way it's gonna have to be. Or that. So if lock color is false, then it returns true because of the not, and that causes the loop to go through. All right, it's a little bit ugly, but I think it will work. Okay, so now we check if the closest doors are traversable. Doors are, locked doors are not traversable, but I added some logic, I added some logic to the distance check or the neighbor check, where if the tile is walkable or the tile is locked door, I say it's a valid path. That way, the path will be calculated, and then if you come back through that path, in the actual path construction at the end, then it will check the locked door and bail out. This may not be 100% accurate, but it could work in the short term. Let me see if I can compile the code. We haven't compiled in a while now. It's been probably an hour and a half. So into file, game line 124. Probably when I did the item generation code, I forgot to close a paren somewhere. Or generate items itself, the procedure. That's what it looks like. Let me make sure I got everything lined up here. Items, generate items, level if. Yep. Possible items, yep. That's it. Unbound top level tile ID, that's an entity, line 156. 156, that is tile ID. Oh, okay. I didn't actually store the tile ID, of course. Let tile ID, level tile at, level, new X, new Y. I think I had saved something from there and deleted it. All right, there we go. Well, it's not that the door auto unlocks. Yeah, actually, that's true. I need to check to see if they have the item in their inventory before I say that the path is not blocked anymore. All right. Thanks, Trev, for pointing that out. Entity, I probably need an entity has item. Member entity items. You're high on ice cream. Yeah, well, that's, you know, I think that it's giving you the right ideas, so there's no problem there. That will just return the item, the remaining list, let's say. That should work, I think. So back in locked. If and lock color, not entity has item, entity, list, key, lock color. Did I not indent all this correctly? Yep. So yeah, that will keep us from choking on the entity already having the key. So we sort of skipped a possible later problem. I think there's still something. Oh, okay. It did actually compile. That's good. Now let's see how hard the game crashes whenever I start doing stuff. There's a couple new things we'll see here. First is we're only going to generate the number of items that... We're never going to generate duplicate items, let's say. Let's just refresh a few times. All right, so we got... Yeah, our doors are open. We got some gems and a key. We got a red key. We got a red gem. Looks like they're doing pretty good. A couple keys there. So we've got 3 doors. And that's enough because we got 3 keys. I guess the gems could be there multiple times. All right, so now we need to test having a locked door with a particular key that's being placed, and I can hard code that in. So generate items. That's in game.sem. Generate items. It's right here in front of me. I'm gonna call it here, generate items. What is happening? Generate. Let's take the blue key out because I'm gonna force there to be a blue key. The backend generate. I keep doing the buffer switching command. I think I'm already brain dead. It's only been an hour and a half. That's great. Generate items. When we get to the end of the items list, I'm going to create another item. So make item. We're going to const that. So I also need to remind myself to do this is temporary. Make item key blue. And I think this is a const pair. No, actually it's not. Make item. Dress says order a coffee and have it come after 40 minutes again. Actually, I didn't finish my coffee, so that could be part of the problem. Make item level spawn for type. Make item must be taken a const pair. So I want that item to show up. Well, it could show up anywhere really, but I need to lock this door here too. So if I have a key, let's say the key is here. So what would that be? 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 3. 3, 6. All right, so let's go. Hey, Peter. Peter says, coffee is life. Coffee is the raw material programs are made from. That's true. Let's double check that my blue key gets added where I expect it to. We'll just hard code some stuff so we can make it testable and see what we get. It would be nice if I could actually write some unit tests for some of this stuff, but we don't have time for that. Unit tests are the only way to keep your sanity whenever you're dealing with logic that is not easy to replicate in a randomly generated game. I'll refresh, and the key is there where we expect. That's good. Peter says, I'm finally adding the bloat part in my attempt. What is the bloat in your game, Peter? I'm curious about what that is. The door at, let's see, 0, 1, 2, 3, 4, 5, 6, 7. 7, 0, 1, 2, 3, 0, 1, 2, 3. So 7, 3. 7, 3. I need to set that tile to something else. So let me go to game right here. After we load the game, I need to go set that tile, which requires I have the ability to set, define set level tile ID, level tile ID XY. So that would be index. Did I have that? Index position. We got index position. No. That's actually not what I wanted. I want the inverse of that. Draw level. No. Modulo I with height. Yeah, it's the other calculation of the width, level width. It's not that one, it's this one, this one, this one, this one. Isn't it? Yes. Level tile at, okay, there we go. Level tile at. Level tile at. We're gonna do the set version of this. Set level tile at. And then that's going to be a vector set. And this vector k, which is this, and then the new tile, which is tile ID. We do need that. So level tile at, set level tile at, and then in the main game, after I load the level, let's see, level current game, game level current game. That's an update. I want to do it at the very beginning. So if I go around level 1, we've already loaded level 1 because it's hard coded. Set level tile at level 1. What was it? Tile ID first and then do this mapx. Okay. X and Y was 7 and 3, and then the tile ID would now be the blue locked door, which we have determined is 549. All right, let's recompile and see if it works. Peter says it's a game where you have to navigate platforms with keys and food. You consume calories when you're running, and your calorie balance determines your bloat. If you're too bloated, you cannot go through the gate to finish the level. Autobiographical game. Well, I do like the idea. I think it's a great idea, actually. Okay, so level tiles. I'm passing in a procedure to level tiles somewhere. Let me go look at level tiles, level set tile at, set level tile at level 1. Oh, right. Okay. So in make game, let me go back into the other game to SCM then, make game. Because I think I call the function to initialize a level right there. And I'll just drop in this little hack somewhere in the middle. So maybe right here. Just get it done. All right, now let's redo it. Oh, level 1. It's just level. All right. Takes its time. Uh-oh. Okay, that actually is a legit song. I was about to say. Lack of reload is not... Oh, I don't know what tab I ended up on. Okay, blue locked door. Excellent. So now we have a blue key and a blue locked door. And I think I've already implemented the logic for this. So if I were to, what was it called? Maybe I need to copy a script. So do, can't be do. Do I need to put an item in there too, just to make it so that there's a way to find a path to inside that room? All right, so we'll do that too. We're already in game, so generate items. We're gonna make 2 items here. I'll do another little const make item gem yellow, and the position for that would be this will be 1, let's say, and 11, I think. Let's say 110. No, 10, 1 is the correct position for that. We'll just nest these consts because why not? Okay, and then in the call to generate items right here, we will take out the yellow gem as well, temporarily. And then we should have a target we can tell one of the monsters to walk toward. And then we can start testing this logic about finding a key that's relative to a path that's blocked by a locked door. But it's very likely that this key will get hit on the way, so I might need to move this key over here somewhere so that it wouldn't be in the path. So in generate items, let's go change that and make the key show up at, it's not 3 anymore. I would call that like an 8. While we're waiting on that to compile, if any of you here are interested in learning Scheme, I'm actually, I've opened up registration for another instance of my hands-on Guile Scheme for Beginners course that starts on June 8th. I've got the link in the description of the YouTube stream right now, but if you aren't on YouTube, if you're on Twitch, you just go to systemcrafters.net and it's on the main page. You can just click the link here on the main page. The orange box. It's an 8-week course with pre-recorded material plus interactive forum, live Q&A sessions, and a bunch of exercises to work through to learn Scheme. So if you are interested in learning how to program Scheme, kind of like what I'm doing today, you should definitely check out the course that starts on June the 8th. All right, so I've got the yellow gem, I've got the locked blue door, and I've got the key. So I need to copy some logic to drop that in. Go back to my notes file because I'd written that out there. Find nearest item. Well, I'll add some specific logic for that. So let's go back into the game and I'll paste this. I'm pressing Emacs key bindings, not normal key bindings. All right, so I'm not going to do find nearest item. I'm going to say find item. Gem yellow. So it's going to try to find the yellow item, sorry, the yellow gem. And then it should see that the path is blocked by a blue door. So it will hit this path blocked logic, and then it will try to find the relevant key to get through the door. And once it finds the key, it should continue walking toward the yellow gem. I hope this works. Otherwise, we'll just debug it, as we always do. Let me just drop this in right here so we can copy and paste it again, because we're going to need it. Let's give it a shot. All right, we've already got a crash. That's fine. Probably the pathfinding logic is busted. Cooter. Oh, I actually did not close out the parens correctly. So that paren right there, I think, needs to be closed. Everything else looks good, so I think I need to restart the game here. Let's restart. Lorid is the name of this one. All right, let's run this. Okay, so yep, just sitting there. Can't find path at desired position. Okay, that's good. It's good to see that it can't find a path, but it's also not proceeding with the rest of the logic. So that gives us something to look at. Let me do this. So can't find a path to desired position. We've got that written out as a message in entity. Can't find a path to desired position. This only happens if path comes back as false. If path comes back as false, then the, let's see, make path action. Oh, and that would be find item. Find item type, find item position. It will find the position, and then it will pass it on to the action. Okay, maybe this is what's happening here, is that every frame we're evaluating that clause. Perhaps if it's not a list, if it's just a plain symbol, then it indicates that something is in the way. So if we say find key, take item. So take item was the thing that we probably executed. Every frame we're trying to take that item. We know where it is. We're trying to take it, but we can't. So at this point, take item action will not proceed. And then what happens in update entity? Maybe we need to return false. And if we return false, we need to continue executing. So interpret actions. If result, interpret actions. And if interpret actions, or maybe unless, then we also need to loop coulter clauses. That could help. Let's see what that does. That might be simpler than adding some extra hooks through the logic. It also means like things like wanderer need to return a true value. Otherwise, did it finish compiling? Not yet. Let's say if tile walkable, let's see. And we need to copy the logic script again. Maybe I need to just make that the default logic script for the moment. No, if I do that, probably I'll complicate things too much. Let's just do this. Okay, it's moving. Okay, yeah, this is what I worried about. It doesn't remember where it's headed. Since it doesn't remember where it's headed, it keeps recalculating that whole chain of events every tick, and then it gets locked into a loop because it doesn't remember where it's supposed to go. Glenn says, did I miss much? We're making some progress, but it's not moving super fast. So, yeah, in a different way. I need to do a similar solution here. So this needs to be a persistent action. Is it not persistent? No, yeah. The problem is that in the script, every frame, we always start from the first expression and try to execute that. So find item is going to locate the position of an item, and then it's going to execute take item, and that action is going to try to calculate the path to an item. And if it can't find the path, it's going to return false, which is going to cause it to fall through to the next one. Path blocked is going to say, oh, okay, so we're blocked by a particular key, so let's find the key. But then in the next frame, it's going to loop back around, and it's going to try to execute this again, and then it will override, or it will try to override the current find key action. The thing is, we need to be able to have a way to prioritize certain actions over others, but it doesn't actually let this work. How can I save that state? Or is there a different way to save all this state? For instance, if we're trying to find a particular item, we need to know that we can't do this action. So this action is kind of blocked currently. And if we try to execute the action again, we should immediately see that that action is blocked. And maybe why it's blocked. How can we represent that? Currently, we are saying that we have a needed key. But that isn't general enough, I think. It's not actually general enough to mark out specific actions that can't be executed. The way that we're looking at actions right now is that if we do a walk to action or something like it, if this ever gets executed, it's first going to look to see what the current action is. And then it's going to compare it to what the action would be if this action got executed. If they have the same parameters, then it skips it. So how would I deal with that then? Is it possible that we could have an action stack almost? Maybe if one action is trying to execute, and then it can't, and another one has to execute in its place, if it's blocked somehow. Yeah, that's still, we're gonna have to implement logic for removing things from that list, which is problematic. I'm trying to think of like other examples. Do we need to actually run the script every frame? Yes, because we need to react to things. So for instance, if we have a clause in the script that says that we need to flee from the enemy, if we go back up to this script right here, at some point we need to execute this hero near flee. But I suppose maybe it doesn't actually do that, unless it's the first thing in the list. So perhaps if you want that to happen, to be prioritized, you need to put it first in the list. And then it will get checked first, and then its action will take place. Otherwise, it will do the other action. So find item. just make this a better example. Has item key yellow, locked door. Otherwise wander. Would be nice to do this too. Like to actually use multiple actions after all. So find item key yellow, take item locked door. Rose says, it sounds to me like we have actions and then conditions that should always be checked periodically or after actions. Hard to understand why I should run the script each frame unless we need to update the script on the fly. Well, we're not running the script. We're checking the list of conditions each frame. The conditions are being checked each frame. We go through them in order. And if the condition is a true, then we execute the action or potentially actions that are associated with the condition. If it's false, we move on to the next expression, check its condition, and then execute its actions. So it's the same script. It's just we're reevaluating the logic each tick based on the state of the world. So if we're already in the process of running some action, we might need to abandon that action. Like for instance, if the hero gets close and you want the character to flee, we need to do that. So I think that's the reason why. And that's why it gets a little bit more complicated to chain things. Yeah, stack route. The thing about the stack route is that it does work because you can search the stack to see what's in there. But you need to also reevaluate the items in the stack. Like when one job finishes, like let's say you're blocked on walking to an item because you got to find a key for the door. Once you find the key, you need to reevaluate the entire stack, let's say, to see which actions are still valid. And that becomes a completely different chain of logic that you have to implement. So if we were to think about this in the specific example of finding a key that's needed to open a door to get to an item, then after you find the key, we're finished with that action, we pop it off the action list, or the action stack, then we see, okay, we have a pending action that depended on the previous one completing. This even works for fleeing, I guess. You're fleeing for a while, but then you pop that off. But I guess the question is like, maybe it just invalidates the whole thing. Maybe the stack is only needed to just say, okay, don't run this type of action right now because there's something else that is blocking it. Okay, that's probably it. I think that's it. I think we don't reevaluate. I think we let the logic do the reevaluation. So let's see, entity, action. I think that's it. That seems right. So entity action, let's see, action state. What are we using that? Entity action. Current action, entity action. Okay, so that I'll leave that one alone. I think entity state is the thing that needs to change. State can be a list. We can push a state onto the stack. Set entity state. Good. We don't call that too many times. Actually, do we ever call it? Never? Interesting. I guess that was something I was going to use for somewhere else. Okay, so set entity action. Sorry, why are you returning that? Set entity action? Oh, because of the exclamation point? No, what the? Weird. The exclamation point did some damage. All right, so interpret action, set entity action. All right, we probably need to change this. Maybe we need to grab the action. So current action. I think we need an API for this. So define. Whoa. Zerkapil says, how did you hide the workspace number? What keybind? I didn't hide it. I'm showing it by holding the mod key. It's if in your Sway configuration, if you're using the built-in with Sway status, there is a what do you call it? Setting for hiding the thing. My Twitch is also System Crafters. All right, so define. As action. Action active, let's say. Maybe that. Entity action. Member entity action entity. I think I actually need to put that first. So action. God. I swear I keep hitting insert all the time. And let's do this. And entity action entity. Because it could be false. What the hell? Fine. Push entity action. Entity action. Aunts action. Entity. Where am I storing the function? Entity action. There's a procedure I'm holding on to. Yeah, it's just a list. Push entity action. We're constantly the action onto the the entity action list. That's action, entity action, yes. And then also we need to make sure that that's a list. So let's do or. And set entity action. Entity. All right, so push entity action. That's the new way to do it. New action. Otherwise, we return current action. We need to make sure it's not already there, though. So entity has action, let's say. Entity action active. What if I just put that here? So entity action active. This could be an if, I suppose. If it's active, then we don't want to try to run it again. Thank you, Circuit Pill. All right, so let's think for a second here. Find key action. So we're going to see if that action is already in the entity action list or stack, let's say. If it is, let me check one of the other ones because I think I'm maybe breaking the logic a little bit. So current action, new action. I made it, Zerka. Let's see. Pair current action. It's true, which means that they're the same. Then return the current action. Otherwise, call make path action. Let me make sure that I understand what that was doing from before. Okay, I const the action along with, ooh, that doesn't work, does it? Yeah, okay. That makes sense. So that check is not as easy as I thought it would be. That's where I was getting hung up. So I can't just do a normal member check. I actually have to either map through all the items or do a custom loop. I would say map is probably easier. Actually, map is much easier because I can just map it straight through car, which is great. So I can check for member action inside of the list where entity action has been passed through car. Or each item of entity action is passed through car. Okay, that's better. Functional programming. So now find key action. It will either return the current action. I kind of need to get that entry though, shouldn't I? Actually, I don't want to. Because I don't want to return the same one if it is not the topmost action. God, I wish there was a mem-p on this thing. Kind of need it. Zerka says, if I want to create a website similar to yours, how much money will it cost? I have no idea. For me, it just costed time. Okay, let's see. I mean, the source code to my site is available, but it's all done with Emacs, so it might be a little bit difficult to repurpose it in that case. Okay. I'm just lazy. I don't want to write a loop right now, but I guess I'm going to have to. Let's do it. So let loop. If entity action entity, that is not needed. I don't need that at all. I can just go straight into a let loop. Now, there's kind of two states here. there is the action is active, but we don't want to continue executing it. And the action is active, and we do want to continue executing it because it's at the front of the action stack. Whose responsibility is that? I guess that's why I'm writing it this way now. So actions, entity, action, entity. And we need to do the or little trick here, or because it could be an empty list. Sorry, it could be false. All right, so we got that. Excuse me. So let's see, if null, return false. Otherwise, we're going to check if equal our car actions with the action. This is scheme. Let's see, car actions action. If it's equal, then we're going to return true. Otherwise, we're going to loop with cdr of actions. All right, so we have actions. The action list is either a list. Well, it's always going to be a list. It's null, return false because we've reached the end of the list. Otherwise, we check to see if the first item of the list is the same as the action, then we return true. Otherwise, we return loop. Now, we can actually do an EQ comparison, I would say. Should I do that here? No. This is really annoying. I mean, the way to solve this problem the right way is to make this a part of the scripting language where a person has to do it. I'm kind of doing more of the work for them. But I don't know. I don't think I have time to add more stuff to the language, so I guess I kind of have to do it this way. So action, if entity action active, if it's entity action active and EQ, wait a second. I need that entry. Okay, maybe this needs to be called something different. It's not a predicate anymore. Active action. So it's an active action of a particular type. Let's call that action type. Action type. Okay. That feels a bit better. And then this can also be current action. Entity, active, action, entity, action. This also needs to be let star. And we should spell things correctly. So now we have the current action for that type. I can do this. Just the EQ. So we're checking to see if the current action is at the front of the stack. If it is, return current action. Otherwise, if And oh, hold up. Yeah, that's definitely the right path. Otherwise, if there's no current action, then we need to make a new action for this. We're gonna call that action type. Okay, so find the current action out of the action stack. We check to see if it's at the front of the stack. If it is, we return it. Otherwise, if there isn't a current action, like we didn't actually find one, then we make an action. And if there is one, we return false. Not current action. Wait, if that will return true, won't it? Oh, if current action is false is true, and then this makes this true. If current action is true, this makes this false, which makes the whole expression false. All right. That's all for find key action. We need to add this logic to everything else. This is why I should have spent the time to abstract this for the other item finding actions, because now we really need it. So this is all basically make path action, right? Because all the same logic could have gone into make path action, I believe. I think. Or something like, let's say, check path action. Consider path action. I don't know. Entity level type item position. And we basically just use the same logic. We're changing too much code here, and I got a bad feeling we're gonna break everything and run out of time. So the type we'll put right here. And that is basically it. Only one thing we had to change. Now this can just be consider path action, entity level find key item position. And then the rest of these, like take item action, actually, I don't need procedures for this anymore, because this all just take item action. Where is it getting called? Right there. So consider item action. Sorry. Am I wrong about that? No. Consider path action. Travis trying to mouse wheel scroll on the stream. I have the same problem sometimes. I'll try to mouse wheel scroll on a screenshot. Hello, Cena. Thank you very much. Clause result. Yes, so this is it. Consider path action. Find key. Hello, Ethan. Ifin. I think the last one is correct. Glad to see you. All right, so consider path action here. It's a little bit different, the implementation, but that's fine. Consider path action doesn't bother me too much. Walk to. And this needs to... clause result is not the position, it's const XY. That is the way. So now I can get rid of the other procedures. I'm telling you, I'm going to break everything. It's about to happen. So now take item action and the walk to action, which are effectively the same, are now gone. And we're calling it consider path action because it's checking to see if the action is already active. The interesting thing here is that this may actually make it possible to look for multiple keys. Possibly. Okay. Now that we've got this idea of a stack, let's actually compile and see if everything's broken. I have a good feeling it will be. Wrong number of arguments to consider path action. What did I do? Entity, I forgot here. Entity. Compilation takes forever. Oh, let's reload. Okay, so nothing. Oh yeah, nothing is happening because I haven't clicked run yet. Let's do that. Good. But that's not broken. And let's go back to notes. And pop this in real quick. Crash. Yep. Crash. That's fine. Irritants. Take item. Entity action. Type check failed entity. I must be calling entity action on something. Where is it? Entity. On something that is wrong. Guessing I'm passing in a parameter wrong somewhere. Not that one. What's the entity in this case? Okay. Entity. Or entity action, entity active action, entity active action, entity action type. Oh, right. I wanted to move the type to the front of the list, because it's the thing that will vary on each call. So let's go back and copy our little script here. Be prepared to run it. Let's reload. I just popped over to Twitch and I see that we got 9 people there. That's great. 9 people on Twitch and about 14 on YouTube. 11 on Twitch. Cool. Happy to see all of you here today. So let me go ahead and paste in this code. See Roj. Another crash. False into car. It's gotta be in the something that we added. Consider path action, car, entity, action, entity. If entity action can be false, I think I just need to not have entity action being false. So set entity action should never, damn it, should never receive a false value. Because it's technically a stack, it's a list. So make entity, when we call into that, we're giving it false. I'm pretty sure that last one is, oh, script logic. So name type, tile ID, X, Y, health, items, state, script, logic, action, needed key. So if we go to the make entity call, we're going to go down and drop in an empty list and false. So let me just mark these so that we know what they are. This is action stack, and this is the needed key, logic, script, state, items. Too many parameters. Great. So now we should have that initialized to be an empty list. We also need to set entity action. So push entity action can do that. Also interpret actions. I believe there's a way for it to return a, okay, what's the default action? Default action needs to be a list. So we're going to do this. Should always be a list. So there's default action. Is that right? Yeah, anything inside of that's actually true. So default action is right here. Unknown action. We shouldn't be setting this anymore like that, because we want to push entity action. We're still not doing that. Push entity action entity. We're going to push whatever action comes in here. Otherwise, we're going to go to the default action. And the question is, when do we clear out this list? Because otherwise we can just keep pushing actions all day. We just check to see if the action's already in the list. So two ways to look at this. One is what to do in this function. And then how do we clear the action stack? Or where, I would say, do we clear the action stack? Because completing any action, whatever the active action is, should clear the entire list, in my opinion. So set entity action, entity. And when we find the item we're looking for, if we reach the position, is there like a callback? Maybe there's a callback. Or we make the path action. Path, find path, if path, const action, when pair path, set entity. So maybe that's it. Because I feel like there's cases where that could be wrong, but we're just going to say to do for now. Peter says, are MPV viewers counted as Twitch viewers? Probably not, because it's not in the actual app or website. So there's probably more people watching that I can't actually see because they're getting the video stream directly, which is fine. Right now, there seem to be an equal number of viewers on Twitch and YouTube, which is pretty interesting. All right. Jeff says, make sure to like and subscribe. Smash that like button, guys. Yeah. Okay, so entity action finished. Entity, come on. I gotta reach a conclusion point in about 10 minutes. So we're gonna see if it's possible to occur. Yee. Join our Minecraft server. Do people do that on YouTube these days? Join our Minecraft server. I'm not trying to make fun of anybody. I'm just, you know. Okay, I am making fun, but not in a malicious way. Just in sort of a... I'm creating a character right now. 389. Is it worse to ask people to join your Minecraft server or to join your IRC channel? What is more nerdy in the end? I don't know. Maybe I should be making fun of myself. Join our IRC channel. irc.libra.chat. #systemcrafters. Yeah, we have a great time. It's like the metaverse, but all ASCII characters. Yes, I did share the post about the voxel game engine. That's different. Come on. It's not just squares. Okay. Peter says IRC is much more cringe. I don't know, is it? I feel like, you know, things like IRC are going to have a little comeback. Or not. Unexpected end of input in entity line 389. Let's go down. This file is getting pretty big. Oh, okay. So somewhere, look, check parens. Boom. Make path action is doing some bad stuff here. I think I did not close off this const. Okay, come on. Starting to lose my patience here. Peter says, with the AI and Microsoft announcements, I see a bright future for retro computing. Yeah, if nothing else, just, you know, people using Linux instead. All right, we're going to reload and paste in the script. Okay, still got a crash. Yeah, we're in a, wow, bad cast. We're even further away from an error that we can discern. Let me think about this for a moment. We need to add some print statements somewhere. This just turned into a big mess. Oh yeah. Oh yeah, Dave. I've reached the end of the ability of the compilation output to tell me what I did wrong. You can blame me for all my bad casts. No, I think for all bad casts, I don't think so, because I'm the one that passed the value in. I'm pretty sure that, well, I'm not pretty sure, to be honest. But it's just a thing that we'll have to debug, and we don't have much time to do it. I need to start logging out all of the things I'm doing. So first of all, in the consider path action procedure, PK considering action type. Dave says users should always see scheme errors. I don't know exactly what I did to cause this, but I'll be able to tell you as soon as I find it. Considering action type, if equal, return current action. I'm going to use the nice little functionality of PK here to do this. PK returning existing action. And I really cannot type, can I? Yeah, I'll take a look and see if I can give you details. We're looking at consider path action. Probably some of the stuff I'm doing, pushing things onto that stack, is causing trouble. Hello to Skippy Blender and Kikenzut. Yes, this is the first stream of the day. And there will be another stream today in 2 hours, which will not be game development. It will be geeks. Skippy Blender says, how come you use Linux over Windows? Might I introduce you to the System Crafters YouTube channel? You should definitely take a look at the videos we have here, because I think you might benefit from it. But to answer your question, I have control over my computer. That's it. With Windows, I do not have control over my computer. Microsoft does, and any other commercial entity that wants to snoop or prevent me from doing what I want to do. So I'd rather use Linux and have total control, and also be able to craft a purpose-built system, as I've done here, that it doesn't have any of the extra junk that Windows does, which it has a lot of junk that serves no purpose, to be honest. Wow, they're all hanging out here in this initial room. Okay. Yes, I need to run the script so that I can get the output. Whoops, I did not mean to delete that. Here we go. We're going to replace everything here. I need a key binding for running. What do we print? Nothing. Okay. Psychic Debugger says I'm not pulling the current action off the list correctly when I'm trying to execute it. So, entity action. Where am I pulling this off? Right here. Action, entity action, when action. So, first of all, yeah, this has got to be it right here. They are ganging up on the hero. That's right. Entity action. This needs to be, when it's a pair. Wait, what? When action. When pair action. Kadar. Because we're pulling the first item off the action list, and we're grabbing the procedure that it has attached to it. Let's try this. I bet that is part of the problem. In fact, hello, Savage Banana Soup. Yeah, let's try this. Skippy says, I haven't looked into Linux much, but after the Microsoft AI announcements, I'm looking for alternatives. Well, I would definitely recommend Debian, Ubuntu, Fedora. There's other Linux distributions that are geared towards people who are used to using Windows or other sort of mainstream desktop operating systems, including Mac OS. So it's much easier these days to get started with Linux. Savage Banana says Linux Mint as your first distro is solid. That's true. I mean, it's also good. I haven't used it, but I know that it has a very good reputation for being easy for people to get started with. I would recommend anybody to try Linux at some point, regardless of what Microsoft does with Windows, because it's kind of like a never-ending rabbit hole of discovery, and you figure out how to use your computers in ways that you didn't think were possible, and also you get a lot of really useful free software that you can use at the same time that cares about not only your freedom as in price, but freedom as in your ability to change the software and make it do what you want, rather than it making you do what it wants or what the creator wants. So that's all I'll say on that for now. Okay, we're just gonna run it the normal way. Good, so actions are working again. Chihum picked up the blue gem. Good job, Chihum. Go back to notes. And there we go. Let's copy the script. We're going to restart. We're going to paste in. All right, now we're getting back to normal stacks again. Considering take item. Savage says, but remember, with great power comes great responsibility. And also inscrutable errors that will keep you pulling your hair out. Good luck, Skippy Blender. Come hang out with us in the System Crafters IRC if you want to learn more about Linux, because we just talk about it all day. So we have an empty list that I'm calling car on somewhere. Okay, that makes sense. I don't know where it is, but you know, we're narrowing it down a little bit. Let's see. It's got to be in the consider logic. Let's see. Consider path action. Which one was it? Was it car? What is going on here? Trev says, why do you keep doing my exact real life voice? Because I have hacked your computer and I've listened to you speak all day. And I know what you're saying about me, Trev. I heard you. You should really be nicer to people. Okay. I'm just kidding. I'm just kidding, Trev. Trev's my good buddy. He knows I'm just kidding. All right, so car is the problem. Trev says Linux users are all hackers, just not really good ones. Keegan Zoot says David Will lives in our walls, confirmed. Nah, not in your walls, just in your computer. Anyone who installs a copy of Emacs gets my virus that I implanted into Emacs. I'm like the Jatan of Emacs. I've added a backdoor so I can get in through some perfectly crafted Emacs Lisp functions and find all your bank account numbers. This is the reason why I'm sitting here doing this right now instead of working a job, is because I've already hacked all your bank accounts and I'm siphoning, 15, 20 cents out at a time. And, I've amassed probably about 20 bucks, so I could buy dinner. It's great. Consider path action. We got a car somewhere that's wrong. Car entity action. I mean, if that's an empty list, then we got a problem. That's probably what Dave said. It's like Superman 3. They did come up with that idea in Superman 3, right? Before hackers did, the movie. Chris says, hey, Nakotani, you would actually lose money from my account. So I would get like a negative balance. That's the way you should do it. So you should always have an overdrawn bank account so that when someone tries to hack your bank account and take your money out, they're actually putting money back in by accident because the subtractions cancel out, right? Is that how math works? I never really graduated elementary school, so I'm not sure. Dave says, I couldn't help but think of Office Space regarding siphoning small amounts. Yeah, that's what they thought. But then they just ended up destroying printers instead. See you, Iffen. All right, I gotta get out of here too. But I am. I gotta figure this out first. Current action. I got my grade 10. Yes. Come on. If it's an empty list here, this is gonna be a problem. If and how could current action be anything? It's because I'm doing an and, right? No, no. Ah. Okay. This here is a little bit pointless. If current action... make path action. If current action is not true... then we should always make it. Yeah, okay. Let's simplify this logic. I felt like there was a way to simplify that to begin with, but now I'm certain of it. If current action and the current action is the same as the entity action. Oh, wait. That's not exactly true. Come on. Chris says, I was sick all week and missed the stuff. Yes, somebody was asking about you today. I think it was Shom. Shom was asking, where's Naokatani in the chat? Okay. I'm kind of out of time here, but I don't want to check this in the way that it is. If there's a current action and it's not equal to the first item in the action list, then I don't want to return it. So maybe I just need to reverse this logic a little bit. This is a little bit nonsensical. I'm not crazy about it. So if there's an action list and current action is equal to the first thing in the action list, which how do we get a current action otherwise? But the logic is bad. Let me just do this. Bad programmer. Bad. My brain can't go through the logic contortions right now to fix that. And not current action. Make path action. All right, so that in theory should fix that. If I can just get the code running again, then we can continue this tomorrow and fix it all. Okay. Should have copied the script. Notes. Let's grab the notes. There we go. Run. Another error. Of course. Of course. Can't find a path to desired position. Okay, that's a... We've proceeded, at least. Can't find a path to desired position. Then we got another cooter that's being called on a false. All right, we're going to have to end it there. I'm not necessarily pleased to end it there. We did not make as much progress as I hoped to today, but we wrote some important stuff. I mean, we're basically trying... Okay, so let me recap what we did. We got doors set up so that you can have open doors or doors that are locked with a particular color. We also started generating items so that you don't have more than one of any given item at any given time. We still need to make sure that there are only as many locked doors as there are keys, but I feel like we may not have locked doors to start with. It may be that a monster needs to go grab a key and then lock a specific door. So they need to lock it before the hero gets there, and then they need to keep the key away from the hero. So it may be something like that. We didn't get to write the hero logic, but we are actually writing some of the necessary parts. We figured out what the hero logic might be. So basically find the nearest item and then take it. Otherwise, if the path is blocked, find the key that will get them through the path. That's sort of how we got on this whole diversion of figuring out which key is needed and then having a stack of actions to keep track of which things are sort of pending. So there's a lot of things that we started writing today that will be necessary to finish the logic, but we just did not get a chance to finish it, unfortunately. But tomorrow is another day, and in theory, we should have another chance to try to get this finished out. I'm guessing that by the end of the jam, most of the basic game flow will work. Hopefully all of it will work, but a lot of the polish and stuff won't be there yet. I may have to spend a little bit of time writing up instructions on a website and not integrating them into the game, but that's okay if I have to do it that way. But anyway, I'm pretty happy with that. The game has been coming along pretty well, and we will try to stream Saturday and Sunday this weekend to get everything finished up, and then the game jam ends Monday morning for me, so I won't have any more time to work on it then. But you know, it's definitely a good effort. It's the most time I've put into any game jam so far, and the result is pretty good. So I can say I'm happy with that at least. So the last thing I mentioned before I go today is I just will mention again about the hands-on Guile Scheme for Beginners course that just opened up registration for the June 8th iteration, or the June iteration. But this is an 8-week course where I teach you how to write Scheme from scratch, basically from the fundamentals of Scheme through how to do functional programming, and then how to use Guile Scheme, the language, in a practical way to do things that might be useful to you in your life as a programmer. So this is mostly like written and recorded material, video recorded material. There's over 6 hours of videos in this thing. It's quite a lot of time to watch me talk about Scheme, but it's all fun. There's also exercises at the end of each chapter, and there is a forum, a discourse forum, where people can go and ask questions about the material. And there's also 4 or 5 live Q&A sessions that there's a schedule for here, where we get together as a group and discuss what we've learned so far, and you can ask me whatever questions you have about Scheme or geeks or programming in general. So if you're interested in learning Scheme, definitely check out the page here. If you're on the YouTube stream, it's in the description. Otherwise, you can go to systemcrafters.net, and on the home page, there's a little orange box here that you can click the link on so that you can learn more about that. So happy to answer questions that anybody has about the course. If you just come to System Crafters IRC, find me on Fediverse, send me an email, david@systemcrafters.net, or where else am I? The forum. Go to forum.systemcrafters.net, anywhere. Just ask me questions if you have questions. Savage Banana Soup says, sounds like your course is less highbrow and more practical. I would say there's a decent mixture of that. I try not to go too philosophical. I'm more like teaching you the actual fundamentals of Scheme, and then real like fundamental stuff, like how to deal with a file system, how to read files, write files, you know, loop over files in the file system. A lot of other things. Oh, taking input from the user, turning Guile scripts into programs, writing your own modules, using modules. A lot of stuff that's actual things you need to know if you want to write programs with Guile. So definitely worthwhile to people who would like to use Scheme in a practical way but haven't had a chance so far. Okay, anyway, thank you all for being here today. Really appreciate your time and attention. I will be streaming again in 2 hours. Not Game Jam, just normal System Crafter stuff. So come back then if you want to see more me talking about Linux and fun stuff. So anyway, I hope you all have a great rest of your day. Until next time, happy hacking. We'll see you.